All right, got another set of gas puzzles from the Cracking the Cryptic guys. Genuinely approachable Sudokus. So hopefully Sudokus that I can do. They all have like these little weird rule sets that are pretty cool, and I have a lot of fun doing these. So I'm going to do another one of these. This one's called For Granted by Bill Murphy. And the rules are that the normal Sudoku rules apply. So need the digits 1 through 9 in every row, need the digits 1 through 9 in every column, and need the digits 1 through 9 in every 3x3 box, and numbers can't overlap in any of those three things. Okay. So also digits along an indicated diagonal must sum to the given total. So I guess that means that 17, so, well, this is interesting actually because we already have a 4 and a 7 here. So these four digits need to add up to 17, and these two add up to 11, which means that these two need to add up to 6, which is telling. Because the only numbers that could be in those boxes are 1, 2, 3, 4, and 5. I don't know if that's worth taking note of yet, but I will keep that in mind. Okay, so let's dive into it. So that was sort of interesting. Okay, so 12 here, though. So these two need to add up to 6, and there's a 4 here. So, and it can't be 3, 3. So these two digits have to be 1 and 5, right? Can't be 2 and 4, can't be 3 and 3, so it's got to be 1 and 5. Cool. Oh, and there's a 5 lined up here, so we actually have some digits. That's a 1, that's a 5. Very cool. Okay, so now we're down to 4 digits in this box that we need to figure out. What else are these diagonal things telling us? Okay, so this 12 one I think might be interesting. Ooh, a 32. That's a really small number because there's 9 digits going down. There's 9 digits on this diagonal. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a 4 and a 7. So we have 7 digits that need to add up to 21. So the average of these boxes, these 7 boxes, has to be 3. Those are going to be pretty small numbers. That's definitely something to keep in mind. Okay, I probably should look at just regular Sudoku first and see if we can fill anything in. I don't think there aren't that many numbers in the puzzle right now, so I doubt we can. Yeah, might not even be worth doing. Okay, so one of these two has to be a 3. Because we've got 3s, 3s, and 3s. So 1s, there aren't any 2s. 3s, I think that's all we're going to get from 3s. I would think. Yep. 4s, one of these 3 has to be a 4. I'm not going to take note of that. 5s, okay, so one of these 3 has to be a 5 now. 6s, 7s, okay, so one of these has to be a 4, one of these has to be a 7. 8s, 9s. Alright, so nothing really there. So let's take a look at these diagonals. So these two boxes have to add up to 5. There's a 4 here. So this has to be 2, 3, right? I think these two have to be 2, 3. Because the 7 means we have 5 left over for these 3 boxes. So they have to add up to 5, and there's a 4 in the box, so it can't be 1, 4, so it has to be 2, 3. No overlap there, but that is limiting. Very nice. Alright, so I was talking about the 17 before. These have to add up to 6. Did this 5 and this 1 help at all? So it could be 1 and then 5. It still could be 3. Oh, it can't be 3, 3, because there's a 3 here. Okay. So it could be 1 and 5. So there's only 3 options, I think, for each of these boxes. Because this one could be, so it has to add up to 6. So we got 2, 4, 5, and 1, 2, 4. Right? Because the only ways to make 6 are 3, 3, 2, 4, and 1, 5. And this box can't be a 5, and this box can't be a 1. Okay, so that's interesting. What else is going on in the diagonals? I feel like it's going to come down. So, ooh, this 2, 3 is actually very interesting. I think, okay, so again, these numbers have to be really low. So we've already eliminated 3, 4, and 5 from this bottom box. So I think that means these two probably have to be 1 and 2. What's the highest number we could have in this line? Okay, so we have 7 boxes here that need to add up to 21. If we had a 9 in one of these boxes, that would mean that we would need 6 boxes diagonally to add up to 12. I guess it's possible. Doesn't seem likely that there's going to be a 9 on that diagonal. All right, wait, there is a 16 here that I haven't looked at all. No, this is going to be helpful, I would imagine. 8 and 4 is 12, 16. So these two boxes have to add up to 4. Could it be 2 and 2? It looks like it doesn't. No, it's not possible that it could be 2 and 2 because there's going to be a 2 in one of these boxes. So it's not 2 and 2. So it's 1 and 3, and then that's fixed. So this is a 3. This is a 1. Awesome. Okay, so that was really helpful. And now that decides this. This has to be a 2. Now this can't be a 2. Okay, we're actually getting a lot of information out of this. Okay, so this can't be a 2, and this can't be a 1. So this can't be a 5, which means it has to be a 4, which means this has to be a 2. Perfect. Now I only have 4 boxes left in here. Ooh, this can't be a... Okay, this number can't be a 1, 2, 3, or 4. This number could be a 1. And it kind of feels like it's going to have to be. Because otherwise this diagonal is already getting big. Like if this number isn't a 1, that means we have to put a 5 and a 6 in this box on this diagonal. Which would mean that we only had 10 left for these 5 boxes down here. And 3 of them are in the same box. So that has to be at least 6, and there's a 3 here. So this has to be at least 7. Because 1, 2, 3 adds up to 6, but there's a 3, so it has to be 1, 2, 4, which adds up to 7. And then, is this going to force a 1 in here? I think it is. Let me do this one more time. All right, so if this isn't a 1, then these numbers at their lowest could be 5 and 6. 5 and 6 here. So let's just, for the sake of it, so this is a 5, this is a 6. That couldn't even, okay, so let's say this is a 5. It can't even be 5 and 6, okay. So this could be a 5, this could be a 7, or what? It would have to be now there's a 9. Okay, so that breaks the entire thing. It absolutely breaks the entire thing. This is a 1. I guess we can just play with this just for the sake of it, but, so 5 and 6 didn't fit in here either way, so, and then the next lowest number is a 9. So, if 5 and 6 don't fit, if this isn't a 1, it has to be 5 and 9 at the lowest. And now we have a 5, 7, 9, 4. So 5 plus 7 is 12, plus 9 is 21, plus 4 is 25. And now we only have 7 to fill up these boxes, right? There's 5 more boxes, and we need to fill them up with 7. 3 of them are in the same box, and these are going to have to add up to at least 7. So this has to be a 1. This doesn't necessarily have to be a 5. That is the lowest number that it could be. But I'm not going to fill that one in yet. But this is definitely a 1. Oh, and that was forced because I didn't even need to do all that logic. That was already forced. Oh, man. Okay. What can you do? All right. So that's a 1. This is probably a 5. If it's not a 5, it's a 6, I guess. It could be a 6. So it could be a 5 or a 6. All right, so what else is going on? Oh, okay, so these 3s are decided. So there's a 3 here. 3s are probably close to done. One of these two has to be a 3. And, okay, this is a 3. Helpful. And then one of these two is a 3. So here, 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 here. Let's mark those up. 3s, 3s. All right. All right, so I haven't done anything with these diagonals yet. Looks like these numbers probably have to be pretty big. Okay, so 1 and 6, and they're adding up to 19. I might as well do these first, actually, because these are even bigger. So, there's a 3, and it has to add up to 18. So these two numbers have to add up to 15. So we could do 8 and 7 or 6 and 9, but there's a 6 here. There's an 8 here. So I think that decides this. That means this has to be a 7. This has to be an 8. It's the only way we can make that work. Okay, and now we've got this situation where we need these two numbers to add up to 12, and there can't be an 8, so it can't be 8 and 4. Could it be 9 and 3? No, can't be 9 and 3. Can it be 7 and 5? So the 7 could go here, and the 5 could go here. 7 and 5 is possible, and that's the only possibility. And it's decided where they have to go. So this is a 5, and this is a 7, because otherwise it couldn't be 6 and 6. Because could it be 6 and 6? Oh wait, it could be 6 and 6. It could be 6 and 6. I have to delete that for a second. Could still be 6 and 6. 6 here and 6 here. There's nothing wrong with that yet. Okay, so this can't be a 7. So this is either a 5 or a 6. Oops. 5 or a 6, and this is either a 6 or a 7. 24 seems like a pretty big number. 18 is a relatively big number. So we need these two to add up to 14. So only ways to make 14: 7 and 7, 8 and 6, 5 and 9. There's a 5 in the box, or can't be 5, 9. Has to be, can't be 7 and 7 because they're in the same box. 8 and 6 are the only options. And I don't think that is determined yet. There's nothing to disrupt that. So 8 and 6 are the only options here. Oh, there is. Oh, there's an 8 here. Okay, I wasn't looking in this direction. Perfect. Okay, so this has to be a 6. This has to be an 8. Okay, now we're looking here. 24 minus 8 is 16. These two numbers have to add up to 16. That's probably pretty limiting as well. Okay, so 16, you can do 7 and 9. I think that's pretty much it. Could be 8 and 8 too. But there's an 8 here, so you can't do it. So 7 and 9 is the only way. So this has to be a 7 because there's a 9 here, and this has to be a 9 because there's a 7 here. Awesome. So we have almost all the diagonals filled out except for these things. This long, long one. Oh, okay, and we just placed a 7 here, which decides this 6. Oh, so this is 6, 6. That's interesting. Okay, so now 6 is placed here. Yeah, I might as well look at Sudoku. There's probably some stuff happening now that we've placed all these numbers. What's going on with 6's? Alright, so there's going to be a 6 there. Is that it? Oh, one more 6. So 6 here. Awesome. That's it for 6's. Let's just run through these. 1's. Okay, nothing decided there. 2's. There's a 2 here. Awesome. That's, oh, 2 here. 2 here. Wow, a lot more happening with the 2's than I was anticipating. There aren't that many. 2 has to be one of these two. Okay. 3's. Okay, still got those those 4 options there. 4's almost down here. We got this one and this one could be 4's. One of these two has to be a 4. This has to be a 4. Okay. Oh, now this is a 3-4 pair. Yep. Okay. One of these two has to be a 4. Oh, and that decides this one. So now this has to be a 4. Awesome. And that's going to decide this one. Okay. One of those has to be a 4, so this one's a 4. Now we've just got these to figure out for 4s. All right. Making serious progress here. 5s. Not a whole lot happening with 5s, but one of these two is going to have to be a 5, which places a 5 here. Awesome. Oh, this number is placed. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is good. Okay. All right, so it's doing 5s. Probably not any more information there. So what are these two numbers? This is probably decided. 1, 2, 3, 4, 5, and 9. I guess it's not decided actually, but okay. Well, those are 5 and 9. So this is a 5. Interesting, because this pair can't have a 5 there. Can't have a 5 here. So the 5 has to go in one of these 3 boxes, and 2 of these are a 3 and a 4. So this one's a 5, which might end up being helpful. Now one of these 2 are a 5. Okay. 6s, I think I did all those. 7s. This is a 7. Awesome. One of these 2 is a 7. This is a 7. This is a 7. I think one of these 2 has to be a 7. And now one of these 2 has to be a 7. And that should do it for 7s. 8s. Oh man, it's not even placed in here. Seems like one of these. Okay, so one of those has to be an 8. One of these has to be an 8. This has to be an 8. Alright, that's going to help with the bottom here. This has to be an 8. This has to be a 7. This has to be a 7. 7s are done. 8s are almost done. So close. Alright, well this is an 8 because one of these 2 has to be an 8. And there's only one other box here, so this has to be an 8, which means this has to be a 9. Awesome. So basically good. This has to be a 9. This has to be a 5. Only one number left here. Is that a 9? Looks like it. Alright. 2 numbers left here. There's one number left here. Is that a 1? That makes this a 9. Which makes this a 1. Any 9s to be decided. So one of these 2 has to be a 9. It doesn't determine anything there, unfortunately. Ooh, okay, this has to be a 9. That's going to make some things happen here. 3, 3, 4, 4. Alright, I mean there must be more stuff. It's not immediately popping out from my notes. Alright, so one of these had to be a 9. And one of these had to be a 9. Oh, so this one has to be a 9 because we have a 5-8 pair there. So 9. Oh, okay, no, I already have a 9 in that box. I was wrong about that. But does that force a 9 here then? It does, yeah. So this is a 9, which is going to help things. So 9, 2, 8, 8, 5. Alright, pretty much just counting to do from here, I think. This is a 1. Oh man, still don't have 1s placed in here. What's this last number? Is that a 2? Okay. What's this last number? 5? Alright, what are the last 2 numbers here? 1 and 2. Is that really not decided somehow? Either one of these could be a 1 or a 2. That's crazy. Okay. How about these two? Is that a 1 and a 2 too? What's going on with the 5s? All right, so there is a 2 in this box. So this is 1 and 5, and this is 2 and 5. Is that possible? Is this not going to be fixed? Is that going to be decided by this? Wow, this is finally going to come into play. I was wondering why this long diagonal wasn't coming into play. That's crazy, though. Okay, so this is 2 and 5, I think I said. No, 1 and 5. 1 and 5. This is 2 and 5. That's wild. Okay, so this number is going to be dictated by this 32 sum. So we got 5 plus 7 is 12, plus 1 is 13, plus 4 is 17, plus 2 is 19, plus 7 is 26, plus 4 is 30, 31. This is a 1. And then that's going to decide the rest of the puzzle for us. And that is how you win the Sudoku puzzle. Awesome. There it is. Thanks for watching. Catch you later.